Welcome once again to my YouTube channel. This time we are going to be having questions on chemistry for those of you that are preparing to writing the forthcoming UNIBEN post UTME. So do well to follow through as I run through about 25 questions that are very likely questions to be set out for the exam. All right. So without wasting further time on that, let's see the first question. Question one. So you have to be very attentive. Question one. Animal charcoal differs from wood charcoal in that it dash. Animal charcoal differs from wood charcoal in that it dash. Of course, when we talk about animal charcoal, wood charcoal, we are simply referring to charcoal coming from amorphous form of carbon. All right, that's under the allotropes of carbon. We have the crystalline and the amorphous or non-crystalline. Then under the non-crystalline, we have coal, we have wood, we have charcoal, we have carbon black, also called soot, and then we have lamp black. Of which under the charcoal, we have about three types of charcoal. We have the animal charcoal, the wood charcoal, and the sugar charcoal. Among the three of them, sugar charcoal happens to be the purest of the amorphous form of carbon. Then looking at the impurity of wood charcoal is sulfur impurity. That of animal charcoal is phosphate impurity. That is calcium tetrahydrophosphate 5 impurity found in animal charcoal. So the question again, animal charcoal differs from wood charcoal in that it A has a dark color, B has a high carbon content, C is a good absorbent, D it is rich in phosphate content. Of course, the correct option is actually D. It is rich in phosphate content. Talking about the impurity, like I said, the impurity that you can get in it is actually calcium tetra phosphate 5. All right, that is actually the impurity. The formula is written as Ca3PO4 then 2. All right, so this is actually calcium tetrahydrophosphate 5. The next question, fructose and glucose are dash. Fructose and glucose are dash. Of course, looking at fructose and glucose, they are considered as monosaccharides, all right? And then they are regarded as isomers because one is a ketose sugar, while the other is an aldose sugar. Glucose is an aldose sugar, all right, talking about the fact that it contains the aldehyde functional group. Then while that of fructose is a ketose sugar, all right, it contains the ketone functional group. By structural representation, it can be reviewed. So they are isomers. So let's see the options. A, allotropes of each other. B, both disaccharides. Like I initially stated, they are both monosaccharides. Then C, dimers of each other. By dimers, we are referring to dimerization. Of course, that has to do with the combination of identical or similar molecules to form one. All right, so that's not it. Then D, isomers of each other. So the correct option is D, which is isomers of each other. When we talk about isomerism, it has to do with having differences in structural representation, but having same molecular formula, because the formula of both of them still remains C6H12 and O6. All right, so they are both isomers. Question 3. Faraday's first law of electrolysis can be expressed mathematically as, so it means they are bringing our mind to the Faraday's laws of electrolysis. There are about two laws, the first and the second. The first law states that the mass deposited during electrolysis is directly proportional to the quantity of electricity passing through the electrolyte, of course. Then looking at the mathematical representation, M is directly proportional to Q, where Q is IT, which is current times time. All right. So this can be illustrated in this pattern. So by the introduction of a constant, you can be having ZIT, where Z represents the electrochemical equivalent. So the options that were provided, A was M is equal to I over IT. Then B, we have M directly proportional to IT. Then C, we have Q is equal to IT. Then D, we have Q is directly proportional to I and inversely proportional to IT. So the best option to go with is actually B, all right, judging from this part, okay? So that's the correct option. Then question 4, which is the next question now. Of course, this question 4 is coming from calculation. So it's a calculation question. Now, this question 4, we are given that 20 cm cube of 0.09 mole per dm cube, all right, solution of tetraoxosulfate 6 acid, which is H2SO4, requires 30 cm cube of sodium hydroxide, which is, let me just go with the formula, NaOH, all right, for complete neutralization. The molar concentration of sodium hydroxide is, now we are told to calculate the molar concentration of sodium hydroxide. This question is taking our mind to titrimetry, that is titration. That has it that we have to work with this formula, which is CAVA over CBVB equal to Na over Nb. Ca is concentration of acid, volume of acid, concentration of base, volume of base, number of moles of acids, and number of moles of base. All right. So now the thing is this: we need to get a standard neutralization reaction for we to know the number of moles of acid and that of base. To do that, we have to represent the reaction like this, and that will ultimately give us a salt, which is Na2SO4 plus H2O. All right, balancing this reaction here ought to be 2 because we have 2 atoms of sodium here, and then the hydrogens are total of 4, so here should be 2. The reaction is balanced if you confirm. All right, now what is now the ratio of the acid to the base? Is actually 1:2. So it means that we have already obtained our values for these two. The concentration of acid is given to be 0.09. The volume of acid given to be 20. We are working with 20. We didn't convert to dm cube because the other volume is also given in cm cube, so you can work directly like that. Then over concentration of base is what we are told to find. Then the volume of the base given is 30. So number of moles of acid, which is 1, invisible 1 there, over number of moles of base, which is 2. So when we cross multiply, I think we are going to obtain 0.09 times 20 times 2, then is equal to x times 30 times 1. Of course, we have, for we to get x, we have to say that it is 0.09 times 20 times 2 over then 30. So we'll cancel out. Then, of course, when you multiply with the help of our calculator, we can as well do that with the help of our calculator. That is 0.09 times 4 divided by 3. I think we are going to obtain 0.12. So 0.12 as our answer. All right. So in the options, we are giving 0.03, we are giving 0.12, 0.27, and 0.45. So the correct option is actually the option of 0.12. All right. So that's that about that. So the next question. Please don't forget the steps that we used here, and don't forget the formula. Also, you should know how to balance reactions. All right. Next question. Which compound is a component of baking powder? Which compound is a component of baking powder? Now, the compound is actually sodium bicarbonate, which is this. All right. Now, this ordinary sodium bicarbonate is called baking soda. Baking soda. All right. Then for baking powder, it's simply a mixture of this guy, which is the baking soda, and usually organic acids. It can come in the form of tartaric acid. So when you mix this with tartaric acid, because you are going to obtain baking powder. So this is an active component of baking powder. The options that were given was A, Na2CO3, then B, Na2SO4, then C, NaHCO3, then D, KH2CO3. So the best option is actually C. All right. So that's the answer to the question. Then the next question. What is the ratio of the rate of diffusion of carbon dioxide to that of propane under the same conditions? All right. And then we are giving the relative atomic mass of hydrogen to be 1, that of carbon to be 12, and oxygen to be 16. Then we are told to calculate the ratio of the rate of diffusion of carbon dioxide to that of propane. So the two gases mentioned are carbon dioxide, and propane. All right. Now propane has a formula C3H8. Carbon dioxide is CO2. All right. Now, taking the relative atomic or molecular weight of this guy is actually 44 gram per mole. Yes. Why? Because carbon atomic mass is 12, oxygen is 16, times 2 is 32, then 12 plus 32 is 44. Then as for this guy, now carbon is 12, times 3 is 36, then 36 plus 8, which is 44 also. So 44, 44. Of course, since they are having the same molecular mass, you don't even need to do anything. You don't need to even run to check in your Graham's law of diffusion, all those trash. All you simply just do, since they have the same molecular mass, hence the ratio of their diffusion would be same, which is 1:1. These were the options. A was 1:001, then B was 1:02, then C was 2:01, and D 2:03. So just that the answer is 1:01. 0:1 is the same as 1. They just want to confuse you. So don't be confused. All right? So that's that about that. Then the next question. The best way to distinguish sodium carbonate Na2CO3 and NaHCO3 is by the best way to distinguish between sodium carbonate and sodium hydrogen carbonate is by, now these are the options: adding an acid, that's option A; option B, dissolving in water; option C, exposing to air; then option D, heating. Now the first thing to know is this: all sodium salt compounds are soluble salts. So it means dissolving in water, you cannot know whether this is this or that is that, because they both dissolve. All right, so that option B is out. You can't add acid to knowing whether each of them is actually this or that. All right, then exposing to air, that one is way out of it. By heating, heating is the perfect one. The reason is because this sodium carbonate is stable to heat. When you apply heat on it, nothing happens, it remains the same. But for this guy, if you apply heat on that guy, which is sodium hydrogen carbonate, you are going to obtain sodium carbonate, you would obtain water, and you would obtain CO2. So it means this decomposes while this one doesn't. So you can easily tell which is actually which. All right, so that's the correct answer by heating, option D. Next question. Which statement best describes the process of oxidation? Which process best describes the process of oxidation? They want to test whether we really understand redox reaction in this question now. Oxidation is simply the loss of electrons, addition of oxygen, removal of hydrogen, increase in the oxidation number, and addition of electronegative elements, removal of electropositive elements. Those are the definitions of oxidation. You can visit my video lesson on redox reaction in this channel, and then you understand better. So now, these are the options. Addition of hydrogen, that's option A. B, loss of oxygen. C, decrease in oxidation number. And D, loss of electrons. Like I said, oxidation is loss of electrons. Of course, you can use this code to remembering it. Oil rig, which is oxidation is loss, reduction is what? Gain. All right? So the correct option is option D. Then the next question. The maximum number of electrons that can occupy the shell having a principal quantum number 3 is, the maximum number of electrons that can occupy the shell having a principal quantum number 3 is, now for you to obtain the maximum number of electrons a particular shell can take is with the formula 2n raised to the power of 2. So this square only affects the n, where n represents the principal quantum number. All right, so we are given the value of the principal quantum number to be 3. So we are told to calculate the number of electrons, the maximum number of electrons. So all you are supposed to do, just plunge in this value here. That becomes 2 times 3 squared, which is 2 times 3 times 3. 3 times 3 9, times 2 is what? 18. So the correct option is the one that carries 18. So the options are A 3, B 9, C 8, D 18. So the answer is 18. All right. Next question. The molar mass of a compound X is 56. The empirical formula is CH2. X is dash. These are the options. A, butene. B, butane. C, this is coming from organic chemistry now, ethene. And D, propene. All right. So now they said the molar mass of the compound X has a molar mass of 56, and then the empirical formula is CH2. So what are you supposed to do in order to obtain the compound X? You have to get the molecular formula. For you to obtain that, you work with the empirical formula, which is CH2, all in bracket N, then equal to 56, which is the molecular mass. So what you are supposed to do here is to calculate the relative molecular mass of this, and then you multiply by N. That becomes 12. 12 plus 2, that should be 14. So 14N equal to 56. So that should be N equal to 56 over 14. That is 4. So our N value is 4. For you to get the molecular formula, it should be CH2 all in N. Of course, our N is 4. So the N will certainly affect everything here. That becomes CnH2n. All right. What's our N? 4. That should be C4H2 times 4. And 2 times 4 is what? 8. So it should be C4H8. The compound with the formula C4H8 is actually what? Is actually butene. All right. So that's that about that. In fact, from here you can even get your answer, because this happens to be the general formula of the alkenes. If you still remember organic chemistry very well, so you can just know that it's a member of the alkenes. So this is not it, this is not, this is not. So the correct option is actually that, because it has 4 carbons. All right. So next question: the alloy used for welding and plumbing contains the alloy used for welding and plumbing contains, then these are the options: aluminium and antimony, B, copper and tin, C, lead and tin, and D, lead and antimony. So they said the alloy used for plumbing and for welding is to contain which of them? Now, this is not it. This is not it. This is actually the answer, because this is also called soft soda. Soft soda. And soft soda is commonly used in welding and in plumbing. All right. So the correct option is actually lead and tin. All right. So that's the answer. Next question. Next question. The atomic number of iron is 26. The atomic number of iron is 26. All right. They said the number of unpaired electrons in iron 3 plus ion is the number of unpaired electrons. Of course, for we to get the number of the electronic configuration of iron, we must work with 26 number of electrons. For we to obtain that, it should be AR, which is a condensed representation of electronic configuration, then 4s2 and 3d6. All right. So for you to lose 3 electrons, because this one means that iron is losing 3, you have to remove 2 from here. You remove this one, the entire orbital there, and then you remove 1, because you've removed 2, so you have to remove 1 here. So you now be left with a arrow and what? 3d5. And for you to draw this, d orbital takes maximum of 10. It should be split into 5 parts. So that should be 1, 2, 3, 4, 5. In obedience to Ohm's rule of maximum multiplicity, that when you are filling the degenerate orbital, you ought to fill singly before you start pairing, because of the fact that you want to reduce the repulsive force of electrons to attain a level of stability. All right. So the correct option is actually the one with 5, because in that there are 5 unpaired electrons, 5. They are just occurring singly. All right. So that's the answer to the question, 5. But the options are A1, B2, C5, and D4. So the answer is 5. The next question. Next question. This one is still a calculation question. It said, how much sodium hydroxide is required to make 250 cm cube of a 0.1 molar solution? Very easy. We are given the compound sodium hydroxide. We are told how much of it, because all the options came in gram. So it means we are told to calculate the mass of it. All right. Then the next, we are given the volume. Volume is given as 250 cm cube. Then, which other thing? We are given the concentration of the solution to be 0.1 molar concentration. It's very easy. When you see questions like this, you are told to calculate the mass. Of course, you need to know the molar mass, because the molar mass of this is given as 23 plus 16 plus 1. I'm working with the relative atomic masses of each of them, and that is 40 gram per mole if you add up everything there. All right. So what are you supposed to do? You use that normal chain formula, which is, if you watch my video lesson on stoichiometry, you will understand this better. It's on this YouTube channel. So over molar mass is equal to concentration times volume over 1000 cm cube, since your volume was in cm cube. So what you simply just do, x, that's what you are told to find, over 40, then times, equal to concentration is 0.1 times volume is 250 over 1000. So when you just cross multiply, of course that should be x equal to 40 times 0.1 times 250 over 1000. 250 into 1000, 4 into 40, 10. 10 times this is actually 1 gram. All right. So the correct option is the one with 1 gram, and it was in option D. All right. So next question. If an element X, please just have your writing materials. You can pause the video to get down everything. All right. All right. Then the next question. If an element X with an atomic number 13 combines with an element Y whose atomic number is 8, the most likely formula of the compound formed between X and Y is, now element X atomic number 13, Y atomic number 8. You don't even need to even check the elements, but those some students want to use the normal conventional way, because the element here is aluminium, then that of this is actually oxygen. Charge of aluminium is +3, oxygen is -2. So it means when you exchange ionic radical to form aluminium oxide, that should be Al2O3. Remember our X was aluminium, so we have to replace it there. X2, then Y3. So the correct option is this one. All right. So there was that in the option. Next question. Which element contains the greatest number of moles? Which element contains the greatest number of moles? This question is very easy. Now, option A, we have 8 gram of helium. Option B, we have 48 gram of carbon. Option C, we have 78 gram of potassium. Then option D, we have 130 grams of zinc. So what you are supposed to do when you see a question like this, the advice I often give to students is just use your calculator, because now you were told the one that has the greatest number of moles, mass over molar mass, that's the formula. That's just what you need to do. Mass over molar mass. Check that of helium. The molar mass of helium is what? Is 4. So when you do that, that should be 8 divided by 4, that's 2. So this one, if the number of moles here is 2, then for this one, let's confirm, that should be 48 divided by 12. 48 divided by 12, that should be 4. So here is 4. Then the next 78 divided by 39, because that's the atomic weight of potassium, which is 2. And then the other one, 130 divided by 65, that's for zinc, that's also what? 2. So the best is actually option B. So the correct option is option B. All right, option B is the right option. That's the most number of moles. Then next question. A measure of the degree of disorderliness in a chemical system is known as the dash. Of course, the correct option is actually entropy, because now we have activation energy as option A, B, entropy, C, entropy, and D, equilibrium. So the best option to go with is entropy, all right, because that's the measure of the disorderliness or randomness of a chemical system. All right. So next question. The green color solution of an iron 2 ion salt, all right, changes to a brown solution of iron 3 ion salt So that process is known as A, conversion, B, elimination, C, oxidation, and D, reduction. It's obvious it's oxidation because when iron changes its oxidation state from +2 to +3, there's an increase in the oxidation number, of course. That is oxidation, meaning this guy was oxidized to that. So the answer is oxidation. Next question. The high boiling point of hydrogen fluoride, which is HF, the high boiling point of hydrogen fluoride, HF, can be explained in terms of dash. Now, one thing that you need to know is this, that hydrogen bond is formed when hydrogen is covalently linked to highly electronegative elements such as this. Meaning, if hydrogen combines with this, it forms HF molecule. If it combines with O, it forms H2O molecule. If it combines with N, it forms ammonia molecule. So if you check, these three, they contain hydrogen bond. And hydrogen bond is responsible for the characteristic high boiling point of substances that possess it. Hence, the correct option is hydrogen bond. Let's check the options. A, covalent bond. B, hydrogen bond. C, dative bond. D, electrovalent bond. So the answer is hydrogen bond. All right. Next question. A calcium atom and a calcium ion have the same dash. A, chemical properties. B, electronic structure. C, number of electrons. D, number of neutrons. Let's check it. Calcium atom and calcium ion. Proton number of calcium here is 20. Electron number of calcium here is also 20 because there are no charge. Of course, if there is no charge, the proton is same as the electron. Neutron number is the mass number of calcium, which is 40, then minus the proton number, which is 20. That should also be 20. Then as for this guy, proton number here is 20, no doubt. Then electron number is 18 because it has lost 2. So 18. Then while the neutron number, remember, is 40 minus 20, which is also 20. So if you check, for calcium atom and calcium ion, they both have the same number of neutrons and the same number of protons. All right. But in the options, they said A, same chemical properties. That's A. Then B, electronic structure. They would not be having the same electronic structure because of the electrons. They differ. All right. Then C, number of electrons, which is wrong. They differ. Then D, number of neutrons. So the best option is number of neutrons. Next question. Which compound will give propane when it is dehydrated by excess of hot concentrated sulfuric acid? This is taking our mind to organic chemistry under the laboratory preparation of alkenes. All right, the laboratory preparation of alkenes. But there is something I would love to clarify on this. So please be very attentive. Those writing this comment post UTME. Now, if you look at this question, they said, which compound will give propane? They wrote it as propane, which is a typo error. I deliberately did not change this. It is a typo error. So don't say that because it is a typo error, then you shouldn't pick any option. You should know that this thing, if you've read, you should know it's coming from the alkenes. Because the alkenes in the laboratory preparation is by the dehydration of alkanols using concentrated sulfuric acid. Of course, at a regulated temperature of about 170 degrees Celsius, then you get a corresponding member of the alkanol being used. So if you are working with dehydration of ethanol, it gives ethene. If you are working with dehydration of propanol, it will yield propene. But look at the compound that was given. Now, they said the which compound will give propane, which ought to be propene now, when it is dehydrated by excess of hot concentrated sulfuric acid. A, these are the options: CH3, CH2, CHO. B, CH3, CH2, CH2OH. Then C, CH3, CH2, COOH. Then D, CH3, CH2OH. Now, take a good look at this. Of course, you ought to know that we are looking at propanol to yielding propene and not propane. Like I said, this is a typo error. So this is not propanol, this is propanal. This is 1, 2, 3, which is 3 carbons, and then it ended with OH. So this is actually propanol, all right, because this is the alkanol functional group. Then while this one is 1, 2, 3, this is propanoic acid because it ended with COOH. Then while this one is 1, 2, which is this is ethanol. So ethanol is wrong, propanoic acid is wrong, this is propanol, which is also wrong, while this one is propanol. So propanol will yield propene. Alright, so the correct option is actually option B. So to the next question. Now, looking at this question, small amounts of compounds of transition metals are sometimes added to glass during manufacture in order to make the glass dash. Small amounts of compounds of transition metals are sometimes added to glass during manufacture in order to make the glass dash. A. Acquire certain colors. B. Easier to melt. C. Easier to mold. D. Little brittle. Of course, the answer is acquire certain colors, because if you check the properties or features of transition elements, you get to know that all of them, they are metals, that's one. And secondly, they are located between the group 2 and the group 3 elements of the periodic table. Then thirdly, they exhibit variable oxidation states. Fourthly, they are partially filled d orbital. Then fifth, you have them to form colored ions. Sixth, they have the ability to form complex ions. Seventh, they have the ability to act as catalysts. Alright, so the correct option is acquire certain colors. The next question. An organic compound gave the following result on analysis. Carbon to be 29.3%, then hydrogen to be 5.7%, then bromine to be 65%. Alright? They said, what is the empirical formula of the compound? And then we are giving carbon to be 12, hydrogen to be 1, bromine to be 80. This is very, very easy. Then these are the options. A, CH3Br, B, C2H5Br, then C, C3H5Br, then D, C3H7Br. Then let's get down to business. Of course, this is very easy. You write it out. Carbon, hydrogen, and bromine. Now, the percentage of carbon is 29.3, that of hydrogen is 5.7, and that of bromine is 65. Normal pattern of calculating empirical formula, you have to divide this by the atomic mass of the element. Then for this one is by 1, which is this, and this by 80. So with the aid of our calculator, we can do this and get our answer. Now let's do it. For the first, which is, we have to divide that 29.3 divided by 12, that gives 2.4, then this of course will be 5.7 because by 1 is the same value. Then 65 by 80, that should be 0.8. So we divide through by the smallest value, which is 0.8. That's the rule of empirical formula. Alright? 0.8. So when you do that, this will cancel out as 1. 5.7 by 8, that should be 7.1, which is approximately 7, because you can approximate, so let's just go with 7. Then for this one, 2.4 by 0.8, that's 3. Why I said you can approximate is because it's 0.1. The range of values that cannot be approximated in the determination of empirical formula is actually from 0.3 to 0.7. There was a time I explained that in my YouTube channel, this channel, so you can check and then confirm. So the correct answer is actually C3H7, that's coming from each of them, now their ratios, then BR. Alright, so the correct option is option D. So that's the answer to that question. Then let's see the next question. The next question. Which metal is a constituent of both bronze and soda? That's talking about soft soda. They are bringing our mind to soft soda that we treated just now. Soft soda. Now, which metal is a constituent of both bronze and soda? Now, soft soda is made up of lead and tin. You can still remember. Then bronze is made up of copper and tin. Alright? So they said, which metal is a constituent of both bronze and soda? So which one is common to both of them? Is actually what? Tin. Alright? So the options A copper, B lead, C silver, and D tin. So the answer is tin. As a matter of fact, bronze is often used in the making of statue. So take note of that. Alright? Don't forget. Then look at this next question. What is the change in the oxidation number of phosphorus in the following reaction? This was the reaction given 4PS plus 5O2 gas to give 2P2O5 solid. Now they said the change in the oxidation number of phosphorus. Now, phosphorus over here has an oxidation number of 0 because it's uncombined state, so it's in a free state, that's 0. The phosphorus here has an oxidation number of +5. How? What's the IUPAC name of that compound? It's called phosphorus 5 oxide. How? This is a compound P2O5. Neglecting this, you don't have to focus on value before each of them. Doesn't really matter. Now looking at this, a compound, algebraic sum of the oxidation number of elements in a compound equate to 0. This is considered as unknown. Then while oxygen in most compounds is -2. So when you multiply this will be 2x, then minus what? 5 times -2 is -10 equal to 0. When you move the -10 to the other side, that becomes 2x equal to what? +10. That should be divide both sides by 2 to get 5. So our x value here is 5. So oxidation number of phosphorus there is +5. So they asked for the change in the oxidation number. A 0 to 2, B 0 to 5, then C 4 to 2, and D 4 to 5. So it's obvious the answer is 0 to 5. From 0 to 5. So that's the answer. Then let's consider the last question. The last question. Now the last question is, what is the IUPAC name of, this was the compound given, now if you are given something like this, okay, let me give you the options. Let me just try the options. We are told to get the IUPAC name of that. 2-chloro, 3-methyl, 3-methyl, then root 2-ion. Then B, we have 2-chloro, then 3-methyl, then root 2-ine. Then C, 2-chloro, then 3-methyl, then root 10. Then D, 3-methyl, then 2-chloro, then root 2-ine. Now let us dissect this question. Let's dissect that. Now, on the board, we are having this. Let me expand it. I want to expand this structure. It can be expanded in this pattern of CH3, which is this guy. Then this carbon, so you link to carbon. Then this guy, I can write it above it, Cl. Then double bonds. Then another carbon, C. Then this bracket simply means that you are directly attaching this guy to this carbon. The bracket implies that anything that you have in this bracket, any number here, you should attach it directly to this carbon. So this carbon is carrying how many of these? 2 of this. So that should be this and this. You get it now, 2 of it being attached directly to it. Why I don't put it at the bottom is because I want to leave the space here due to these double bonds. This double bonds implies that you shouldn't be having anything under it. I can decide to bring these 2 down while I will not be writing anything above each of them. Alright? So now, looking at this. This is considered to be the longest, the parent. The parent chain is this. How many carbons are there in the parent chain? 1, 2, 3, 4. And 4 is boot. So let's check the one that does not have any boot. Of course, all of them carries boot. Then next, we have carbon to carbon double bonds. We didn't have anything like triple bonds there. It's double bonds. Now, since we don't have anything like triple bonds, it's double bonds. Triple bonds is to ion. So it means option A is wrong already. Then we are left with these 3 because of the boot 2 ion. Alright, so there are no triple bonds there. Then next. Now we have double bonds. And this is the parent. Let's get the parent name. 1, 2, 3, 4. Boot first. Then number forward. 1, 2, 3, 4. And number backward. 1, 2, 3, 4. Normally forward, the carbons carrying the double bonds are carbon 2 and carbon 3 for forward, and backward is also 2 and 3. So it means in this case we can go with any direction. You get the point, but that's not the main thing. But we can go with any direction because 2, 3, 2, 3. Then now, if you are going with forward, between 2 and 3, which one is smaller? Is 2. So you go with the 2. Put 2 in. You go with the smaller value, not the bigger one. Then next, do we have substituents? Those things that are not part of the parent chain? Of course, yes. We have this and we have this. Now, if you are going with the forward, then 2 is to chloro and 3 is to methyl. But if you are going with the backward, 2 is to methyl and 3 is to chloro. Now the question is, they are both giving same values. So what are we supposed to do? This is it. Now, if you check the options, you will observe that you have the other 3, 2 chloro, then 3 methyl. So which do you go with? You have to now obey alphabet. Yeah. Because now, since both of them, they are having same values, forward and backward, you have to obey alphabet in that between C, because this is spelled chloro, then this is spelled methyl, first letter. Yeah, this is chloro. This one is what? Methyl. C and M. Which one comes first? Is C in the alphabet. So we are going with forward. So that should be what? 2 chloro. You arrange them in the order of alphabetical arrangement or order. That should be what? 2 chloro, then 3 methyl, then what? Put 2 in. Where do we have that? We have it in option B. 2 chloro, 3 methyl, put 2 in. What makes this to be wrong is because this is butene, so it's wrong, not put 2 in. Then why this one? What makes it to be wrong is because of the misarrangement. In that they brought methyl first before chloro, and which is wrong because order of alphabet C ought to come first before M. Alright? So it's my hope that you've been able to understand everything that we have explained. So do well to hit the like button if you love this video, share to your friends, and always stay glued to this channel as more will be dropping. Alright? So I wish you guys all the best. Don't forget to go through this over and over and over again for you to understand concepts better. Thanks for watching and remain blessed.